approximately 25%, or 1 out of every 4 gallons of non-agricultural water consumed in the United States is used for thermoelectric power generation. Now, thermoelectric power generation is a typical power plant. It's anytime you use a fuel source like coal or nuclear to heat, to create steam and spin a turbine. And now this water is consumed for power plant cooling, and as this picture shows, oftentimes the big plumes of what looks like smoke is actually water vapor that's evaporating from the cooling towers. And so, again, 1 out of every 4 gallons of water that's non-agricultural that is consumed in this country goes to produce the electricity that turns on our lights. And then,
so the connection goes both ways. Electricity is needed to get water to us, but water is needed for
certainly,
electricity.
Yeah. So there's definitely a synergy there where you save
ways.
one, and yeah, it goes both ways. And and then just below that, you can see that 49% of all water withdrawals are for electricity, for thermoelectric power production. And so that actually means that more water is used for power plant production than for agricultural use, which is about 40%. Now again, a lot of that 49% of withdrawals ends up being returned ultimately back to the source and not evaporated, but it's still a very, the largest water user and the fastest growing water using sector in the United States is power production.
I would guess that most Americans haven't the slightest idea, that they would say agriculture is the place.
And there's certainly good reason, because agriculture, all the water that's used, or the vast majority of it, tends to be a consumptive use. It tends to be lost through evapotranspiration or, embedded in the food that ends up being grown. And so the water that's used for agriculture doesn't return. And so a lot of the times people tend to discount the energy use because a lot of that water is returned, but it's often polluted and it's often at a higher temperature and at an altered state due to the way that what they use the water for. And on average, to get back to consumption, about 2 gallons of water is consumed for every kilowatt hour of electricity produced. And so again, in a way you can think about turning on the lights is somewhat similar to turning on the tap, because a lot of water ends up being used to and consumed even to produce that electricity.
So what, give us an idea of what a kilowatt is. So 2 gallons per kilowatt, what would a kilowatt of electricity power?
That's a good question. So I mean, if you think about a light bulb, a 100-watt light bulb, running that for 10 hours would end up being 1 kilowatt hour. So again,
so it takes 2 gallons of water on average to run a light bulb for 10 hours.
Yeah, that's a good way to look at it.
Okay.
Yeah.